The first thing I should say is that if you're going to add this when you're already halfway through your project, there are two main things that you're going to have to change. So one is all of the lights in your game, you're going to have to shift them to a different render layer. And two is that you're going to have to reserve two render layers in your game for this effect. So if you're already halfway through your project, this might be a bit of a pain in the ass for you to do. But we kind of have to use that. So by render layer, I'm referring to these, the layer names for 3D render. So out of all of these bits that you have here, you should reserve two of them for this effect. One we're going to be using to basically disable the lights on the other cameras, and the second one we're going to be using to actually show up each of our post-processing volumes individually. So let's get started. The first thing you're going to do is add a viewport into your game. And then what I'm going to do is head to project settings, go to display window, and find this width and height of my game. So this is the resolution of my game, 1024 by 600, which is the default for Godot. And what I'm going to do is divide that by 4 and set that as the resolution of the viewport. So 1024 by 4 and 600 by 4. And the reason we're using such a low resolution is one, that it saves performance, and two, we're going to blur this to all hell afterwards, so it doesn't really matter that this is a low resolution. You're not going to be able to tell the difference later on anyways. Then make sure to enable transparent BG. Make sure to enable keep 3D linear. This is going to be important for preserving the colors. Even if you have tone mapping in the rest of your game, just make sure that this is keep 3D linear on this one viewport. And then enable VFlip and set update mode to always. We're enabling VFlip because when we're going to use the texture sample later on, we're going to need to texture it using the regular UV coordinates, and so we need it to be flipped vertically so that it comes out correctly on our screen. And then the second thing is to set the update mode to always, because it will not update if on a viewport texture, because it does not know when the viewport texture is visible. So by default it is set to when visible, but the problem is this viewport is technically never visible. It's sending its data to a viewport texture that is going to show up on a shader later on in the video. Underneath that viewport, you're going to add a volumetric camera. Now this is just a regular camera node. You can use any camera, clip camera, or the AR VR camera, whatever applies to your game. It should just be a camera node. And then we're going to do two things here. We're gonna black out any one bit. So remember I told you to reserve two render layers for this effect. Well, you're gonna black out one of those layers on the camera, and you're gonna put an environment on it. The environment is gonna have its mode set to custom color. It's just gonna be black, energy 0, ambient light set to 0. There should be no ambient light, and the tone map should be linear. Again, we do not want to tone map this. Make sure that this is set to linear, and that there is no ambient light. The resultant is that if you preview this camera, the whole screen should be black, because this camera should only be able to see volumetric lights. Underneath this, we're going to put a color rect. Make sure that this is set to full rect. So the way you can do that is on a different camera or canvas layer or something, you can add a color rect, set it to full rect, and then move it underneath this camera. And so what will happen is it'll actually go underneath this camera and be placed in the full rect on that camera. So that's important. Now on that on this color rect, come to the material, add a new shader material, add a new shader, and we're just going to write a really simple shader. Shader type canvas item, just define a blur amount, and then sample the screen, which is the screen texture on the screen UV, and then in the third argument put blur amount. This is going to be sampling it at a different MIP level. The cool thing is Godot automatically generates MIP maps for the screen texture in Glass 3. Basically, using a blur amount on the MIP level, what we're doing is just getting a free Gaussian blur, which is already done by Godot internally all the time. We're just going to be accessing that here so that we don't actually have to write a Gaussian blur shader and waste a ton of performance. We can just make use of Godot's inbuilt one. Who the hell messaged me on Discord? I'm sorry, I'm going to have to cut that out in post-processing. Color.rgb, we're just going to set that to be the screen color. So now whatever we sample, the blurred screen texture, we're going to take that and then put that into the output color of our fragment shaders. It's a very simple shader. It's just 8 lines of shader code. Close out of this and head to our main camera. So now you can add this onto the main camera. You can add this underneath your UI. You can add this on a canvas layer. It doesn't matter. The point is that there should be a color rect somewhere in your game that is being applied on top of the rest of the game. So this is the second color rect, by the way, not the same one. And so again, very simple shader. So we're going to put another shader on this, and it's going to be a canvas item. Set the render mode to be blend add, because we want to make sure that it additively blends onto everything that's in the scene, so that when we have black, it does not actually show up as black, but rather it additively blends to the rest of the scene. And then two uniforms. One is going to be the viewport texture, and one is going to be the alpha. So the viewport texture is going to be this viewport, which we're going to sample, and then the alpha is just going to be the strength of the volumetric lighting effect. In the fragment, two lines of code, okay? Sample the viewport texture using the UV coordinates, grab its RGB values, put it in volumetric color, and then second line of code, make a vec for the first three values is going to be volumetric color, the last value is going to be our alpha uniform, and set that as the output color of this thing. Now the alpha, you can play around with it. It's arbitrary. You can use it to change the strength of the volumetric lighting effect in your game, so you will be playing around with this value later and seeing what you like. Now before you try putting the viewport texture, make sure local to scene is enabled. You'll check local to scene, and then here you'll go down and you'll find the last option which says new viewport texture. You'll click this and then click on the viewport that we just made earlier, right? And then hit OK, and boom, now this viewport texture is now attached to this camera. There we go. So now we have the full setup for volumetric lights in our game. How do we actually make a light volume though? That's very simple. This is where we're going to be making use of the second render layer. So what we're going to do is just make a cube, which to make a cube. I'm not joking, we're just going to make a cube or any shape. You can use any mesh, a sphere, a cylinder, a prism, or a pyramid, or even a random mesh that you made in Blender and you can import. The point is just make a mesh instance, put that mesh in there, and then under the material, what you're going to do is take a new spatial material, and then you're going to do three things. One, make it unshaded. Two, set the cull mode to disabled. And three, set the albedo value to whatever color you want the mesh to be, right? So you can make it like pure red or whatever you want, right? Now, in my case, I actually kind of just fiddled around a bit and I wrote a custom shader. If you want, you can copy the shader. You can pause the video and copy the shader. But basically what I did is just that it's a simple shader where when you're not looking at the cube, you can see that it becomes black, and then when you look at it, it becomes fully bright. So what happens is, like, when, for example, if the camera is here, the volumetric light effect will not fully activate unless you're looking straight at the object. So like, if the object is in the center of the screen, its brightness will be maximum, whereas if it's to the side, it won't show up at all. And that's basically how you're gonna have these volumetric lights set up in your scene. And so you'll notice that we have this thing, and now you have to do this very important thing, right? Scroll down, and under visual instance, we're gonna make this only visible on that second render layer. So remember, I told you to reserve two render layers for this effect. Well, we're gonna make use of the second render layer now. The first one we used for the lights, and the second one we used for these instances. So as you can see here, if I go to the volumetric light, I blacked out one of the render layers, and this is the render layer that all of my lights are on. So if you look at my game, pink omnilight, this is on render layer number 11. Blue omnilight, this is on render layer number 11. And I can show this to you, like when I enable these two lights, you can see they're right here. They work perfectly fine, but they're present on number 11. So on the camera, the volumetric camera, we blacked out number 11 because, again, we want it to be pure black. We don't want it to see any of these lights. We only wanted to see volumetric lights and no other lights, okay? So that's why we did that. And so now these lights are basically invisible to it because we have blacked out that render layer. And now the next thing which we're going to do is that we're going to put these volumetrics on the second render layer. And what we're going to do is we're going to black this out from the main camera, because remember, the main camera should not be able to see any of these big cubes in the game, because this is going to be applied in post-processing as a volumetric lighting effect. We don't want this to see any of these cubes, so we're going to put them on that second render layer and then black that out from the main camera. So what you get is that now, for example, if I go to the volumetric camera and I preview it, you'll notice, whoa, look at that. Okay, this is our volumetric light. This is that big cube that we have. I'll actually go, so this is where the camera is located, and you can see this is what the camera sees. So right here, this is the scene, and you can see this is our volumetric light cube that I just showed you. And this camera, when we preview it, you can see it can only see the volumetric light, the rest of the world is just blacked out, pure black, right? And the reason I'm actually making use of these regions as being black is because it will properly cull. So like, because this camera can see the rest of the world, it will actually properly cull out the volumetric light, so that if you don't want the volumetric light to be seen when you're behind a wall, it'll actually cull it out. But the difference is, because the whole world is black, when it gets culled out, it's basically just being wiped off with a black color, which basically means no volumetric lights are being added, which is exactly what we want. We are basically done with our volumetric lights. So here I set up a bunch of volumetric lights. I made this one, I made another one here, which is this pink volume. I made this one over here. Oh, oops. I made this one over here. I made this pink one over here. And I made another pink one over here. And so you can see these are just a bunch of volumetric lights in our scene. And so now when I run the game, what you'll notice is that we can actually see each of these volumes. Now, the effect has been greatly exaggerated over here. And I actually forgot to mention one thing. If we go to the volumetric camera, there's a script attached to it. What it does is it takes the main camera path, and it has a variable called main camera, and what it's going to do is just set its global transform to be the same as the main camera's global transform. This is just so that the volumetric camera and the main camera are both seeing the exact same thing. So what you're going to do is, whatever the main camera is in your game, you want to make sure that this volumetric camera has the exact same transform as that camera. Over here I have set the blur amount to 1, so it is greatly exaggerated. Ideally in your game you'll have this set to about 10, which results in something like this. But I'm setting it to 1 so that it's very, very exaggerated and you can see the effect clearly. So when I run the game, you can see the whole light volume that is being defined here. You can see this, you can see these two light volumes that are over here, and you can see this big light volume that's over here, right? But in your game, what's going to happen is you're probably going to set the blur amount to something like 10, and so it's going to look a little more natural. So you notice when I run the game, look at that. Doesn't that just look beautiful? And you can see exactly what I meant by the resolution being low not really mattering, because here again the resolution is still like 4 times smaller than the rest of our screen, but it does not appear pixelated because it's been blurred really, really heavily, and so you can't really tell the difference. And so I'm actually going to show you a little before and after right here. So I will be switching this to a full screen view, and then I'm gonna move the camera over here to like a nice sort of screenshotty position, and I can show you what it looks like with and without the volumetric lights, right? Okay, so now you can see this is what it looks like with volumetric lights enabled, and then now if I just black out all the volumetric lights, that makes a huge difference, doesn't it? There's like a lot of stuff missing, and then if we enable it again, you can see that, right? And if I move here, like this is something you really would not be able to achieve this without volumetric lights, right? This is like a cool gradient that you're applying across the screen, and it just looks super cool. And again, I will disable it so that you can, oops, I did the wrong thing. I will disable it so that you can see exactly what that looks like. So yeah, it really does make a big difference. I mean, this works, but there's a tiny issue with it, and that's like, if I go inside this volume, for example, what you'll notice is that it's not really a volume because it's a mesh, it's a surface mesh. What happens is it only displays the color on the surfaces or on the edges of the mesh. What I want is that when I go inside, my whole screen should be filled with this volume of light, because you can imagine it's sort of like a solid block. So when I go inside of the block, my whole screen should be filled with that color. And so that can be done with the power of shaders. So I have done that for this volumetric cube right here, and I will disable all of these so that you can see the effect of this on its own. This volumetric cube, I've used the full screen quad technique, which means you take a quad, make it size 2 and then inside of the shader set the position to be vec4 vertex 1.0, and then set the color to be the same as the uniform color. And so what this does is that, and make sure that the extra color margin is max. What this does is that it'll basically make the quad take up the full screen. So even if I like look all the way over here, the quad, when I enable the quad, it'll take up my full screen and fill it with that color. And so what I did is attached a collision shape onto this, an area, and then whenever the camera enters this area, we're just going to enable this quad so that it fills up the entire screen, whereas when the camera is outside of the area, it will not enable the full screen quad at all. And so that's basically just this really simple piece of code right here. And if you look at the main camera in game, which I can do over here, you can see that it has an area node on it, and it has a collision shape. So whenever, and it's also in a group, I forgot to mention that. So if I go here to node and I go to groups, it's in a group called camera area. So now what happens is whenever the camera enters this region, the camera area will send out a signal that the camera entered, and then you can set the full screen quad to be visible, whereas when it exits, we'll set the full screen quad to be invisible. And so the effect you get from doing that, and you can see, yeah, so this is our volume, and when I go inside, it fills the whole screen. And yeah, that's pretty much it. I learned this effect from watching the first devlog of GenoKids. They have a really cool devlog which explains how they did this effect. I posted it in Ombrus' Discord server, and then just decided to take up the challenge of doing this in Godot 3.4. I've just shown you one technique of filling up the whole screen when you go inside of the volume. There are other ways to do it as well. If you have some way which you'd like to let me know about, please tell me, because I was also struggling with this effect where like you go inside and it fills the whole screen. Lastly, on this channel I do a lot of shader related videos, so definitely like and subscribe if you want to see more of that kind of content and you want to be notified whenever that happens. I make a lot of shader videos and VFX and a bunch of crazy stuff over here, so yeah. Anyways, thank you so much for watching, and I will see you all next time.
Enchanté.